सो पावर इनडिटर्मिनेट फॉर्म्स में से हमने पहले ही 1 रेज पावर इन्फिनिटी टाइप देखा इन लिमिट्स L8 और आज के वीडियो में हम पावर इनडिटर्मिनेट फॉर्म ऑफ द टाइप 0 रेज पावर 0 देखने जा रहे हैं. And we know from limits L8 that an indeterminate form of the type such that we are computing the limiting value of limit x approaches to fx raised power gx, and when fx भी 0 को जाएगा and gx भी 0 को जा रहा है, then this form is said to be a power indeterminate form of the type 0 raised power 0. Now, why is it so that the limiting form limit x approaches to fx to the power gx is an indeterminate form? Simply because when fx 0 को जाएगा and gx भी 0 को जाएगा, we can not simply determine कि ये form limit x approaches to fx to the power gx कहाँ जाएगी. So we cannot exactly determine its value. So that's why this form will be called an indeterminate form or undeterminate form. So as an example, if we observe these two examples, so like if we have to compute limit x approaches to a x raised to power 0, x raised power 0, then simply we can say x raised power 0, x any number raised power 0 with 0 as exception here because we say 0 raised power 0 is an indeterminate form. Now x raised power 0 ये value this will be equal to 1. So we can write limit x approaches to a and x raised power 0 is 1 and as such इसका limiting value 1 होगा. But on the other hand if we observe this limit x approaches to a 0 raised to power x. Now 0 raised power x means 0 is multiplied with 0 x times. So this will be limit x approaches to 0, 0 into 0 into 0 x times 0. So this is x times 0. And we know product of limit of product is product of limits and upon each limit we will obtain 0. So this will be limit x approaches to 0, 0 and this will be thus 0. So that means कि x raised power 0 का limiting value अगर compute करे that is 1 and 0 raised power x का अगर limit compute करे that is 0. But both of these forms are 0 to the power 0. So these are both 0 raised power 0 forms. और इसका value 1 but इसका value 0. That means कि दोनों ही केसों में अलग अलग एक वैल्यू आया. So that's why these are called indeterminate forms. And actually there are lots of ifs and buts while reasoning out these power indeterminate forms. A few answered while still a few remain unanswered. As an example, Euler took the numerical value of 0 raised power 0 as 1, but the current mathematicians state that 0 raised power 0 is undefined. Now 0 raised power 0 indeterminate form को लेके कुछ example solve करते हैं and we know if we have to solve the power indeterminate form of the type 0 raised to power 0 और यहाँ पे when x tends to 0 this will be 0 raised power 0. So this is power indeterminate form of the type 0 raised power 0 and we know कि अगर हमें 0 raised power 0 indeterminate form solve करनी हो तो पहले हम इस 0 by 0 form को 0 into infinity type में solve करेंगे by taking log and then वहाँ से infinity by infinity form या 0 by 0 form में convert करके वहाँ से फिर L'Hopital's rule apply करके limiting value निकालते हैं. So then if y is the limiting value of this thing, let y is the limiting value, let y is equal to limit x approaches to 0 x raised to power x. Next as we know from limits L8 so we take log on both sides, so it will be log of y is equal to so log of limit x approaches to 0 x raised to power x and this will be log of limit is limit of log, so it will be limit x approaches to 0 log of x raised to power x and we know we can further write this as limit x approaches to 0, so this will be x log of x log of x because we know log of a raised power b is b log a, so x यहाँ आगे multiply होगा. Now this is reduced to when x approaches to 0, so this will be 0, and log of 0 is infinity. Now this is reduced to 0 into infinity type. अब यहाँ से 0 into infinity type में हम इसे 0 by 0 form या infinity by infinity form में convert करेंगे. And we again know that procedure from the previous videos कि कैसे हम 0 into infinity type को 0 by 0 form या infinity by infinity form में convert करते हैं. And we will write here limit x approaches to 0, so it will be log of x divided by 1 over x. Now when x approaches to 0, so this will be log of 0, which is infinity, and 1 by 0 is infinity. Thus this is reduced to infinity by infinity form. That means we will be applying L'Hopital's rule, and we again know कि L'Hopital rule में हम differentiation of the numerator and differentiation of the denominator करते हैं. So log x की differentiation 1 upon x divided by 1 by x की differentiation minus 1 by x square. So next we can write this as limit x approaches to 0. So this will be 1 by x, और ये minus 1 by x square reciprocal लेके minus x square divided by 1, which will be limit x approaches to 0. So this will be minus x, and when x approaches to 0, and this will be 0. So which means log of y is equal to 0. So taking e as base in order to cancel out this log, so it will be e raised power log of y is equal to e raised power 0, and we again know e raised power log of x raised to power m is equal to x raised power m. So as such, e raised power log of y will be y only. So e raised power 0 is 1. That means the limiting value is 1. So the next example is limit theta tends to pi by 2 cos of theta raised power cos of theta. And when theta tends to pi by 2, so this will be cos of pi by 2, which is 0, and cos of pi by 2, which is again 0. So this is an indeterminate form of the type 0 raised power 0. That means we'll be again first of all converting it into 0 into infinity type, and then into 0 by 0 form or infinity by infinity form. अब 0 into infinity type में लाने के लिए, so we'll write let y is the limiting value of this thing. So we'll write let y is equal to limit theta tends to pi by 2 cos of theta raised power cos of theta. So taking log on both sides, so which means log of y is equal to again log of this limit will be limit of log. So we can write limit theta tends to pi by 2 log of cos theta raised power cos of theta. So again this will be limit theta tends to pi by 2. So cos theta फिर से आगे multiply होगा. So it will be cos theta into log of cos theta. So now this is again reduced to 0 into infinity type, because when theta tends to pi by 2, so this will be cos pi by 2, which is 0, and log of pi by 2 log 0 is infinity. So this is 0 into infinity type now. So converting into 0 by 0 form or infinity by infinity form, whichever is possible here. So we'll write limit theta tends to pi by 2. So we'll be writing log of cos theta divided by 1 by cos of theta. So this is reduced to infinity by infinity form. Next we'll be writing this is equal to limit theta tends to pi by 2. So log of cos theta as it is. So log of cos theta divided by 1 by cos theta को as sec theta लिखेंगे. So now this is infinity by infinity form. That means L'Hopital's rule is applicable. So this is limit theta tends to pi by 2. So log of cos theta की differentiation minus tan theta divided by sec theta की differentiation, that is sec theta tan theta, और tan से tan cancel, so that means we'll be left with limit theta tends to pi by 2 minus 1 by sec theta. So limit theta tends to pi by 2 and minus 1 by sec theta, so this will be minus cos theta. Now when theta tends to pi by 2, this will be minus cos of pi by 2, and pi by 2 is 0, so this will be 0. That means log of y is equal to 0. So again, in order to cancel log, so we'll be taking e as the base, so e raised to power log of y is equal to e raised power 0, and e and log will cancel out because they are inverses of each other, and y is equal to e raised to power 0, which is 1. That means again इस case में भी limiting value 1 है. So next example is limit x tends to 0 sin x raised power tan of x, and when x tends to 0, so this will be sin 0 raised power tan 0, and sin 0 is 0 and tan 0 is 0, so this is 0 raised power 0 type. So that means we'll be writing let y is the limiting value, let y is equal to limit x approaches to 0 sin x raised power tan x. So taking log both sides, so log of y is equal to, and we know log of limit is limit of log, so it will be limit x approaches to 0 log of sin x raised power tan x. And next we can write this as limit x approaches to 0, we know log of sin x raised power tan x, so this will be tan x into log of sin x, and this is now reduced to 0 into infinity type. अब यहाँ से 0 by 0 form या infinity by infinity form में convert करेंगे by writing limit x approaches to 0. So this will be log of sin x divided by 1 upon tan x, which can be also written as limit x approaches to 0 log of sin x, और यहाँ से 1 by tan x को लिखेंगे as cot of x, and then we can write this as अब infinity by infinity form obtained हो गई. That means we will be applying L'Hopital rule and we will be differentiating numerator and denominator. So limiting value होगा limit x approaches to 0 log of sin x. अब log of sin x की differentiation पहले sin x 1 by sin x और sin x की internal differentiation that will be cot x. So overall इसकी differentiation होगी cot x divided by cot x की differentiation minus cosec square x. So this will be limit x approaches to 0 cot x into, अब ऐसे भी लिख सकते हैं -1 divided by cosec square x, which is limit x approaches to 0. So cot x will be written as cos of x divided by sin of x, and this can be written as cosec square x को ऊपर ले आइए, so it will be minus sin square x, और sin से ये sin cancel होगा, so we'll be left with limit x approaches to 0 minus sin x into cos of x, and when x approaches to 0, so sin 0 is 0, so this will be 0. Now log of y is equal to 0 means taking e as the base again, so e raised power log of y is equal to e raised power 0, so which means y is equal to 1.